So standard deviation, okay, what is the standard deviation? Now again, this is a topic I've seen most of the students wondering here. If you understand the concepts, it's pretty. कुछ भी नहीं है, जैसे weighted averages में है, you need to understand the concept, that's it. So what is the standard deviation? It is the measure of the dispersion of the set of numbers around the mean, right? That means how much each number is away from the mean, right? How each number in the set is away from the mean. For example, if I talk about the range also measures the dispersion of the data, right? That is the greatest value minus the least value, right? So, but it takes into account only the two number in the set, right? That is the greatest number and the least number, and tells you that how much dispersion is there in the data set. Similarly, standard deviation also measures the dispersion in the data set, but instead of the two numbers only, it takes care of all the numbers in the data set. Now, how it takes care of all the numbers in the data set? That is, a standard deviation tells you that is how much each number in the set is away from mean of the set, right? So that means whenever we have to find out the standard deviation, the first thing is we need to figure out the mean. The second thing is we need to figure out, okay, how much each number in the set is away from the mean. And that is how we find out the standard deviation. But on GMAT, definitely you do not have to find out the standard deviation, but you need to know that what are the things how you need to figure out the standard deviation. But you do not have to really calculate it, right? So let's do this. So for example, here, if we have to calculate the standard deviation of the data set 13579, right? So as said, the first thing is you need to find out the mean, because what you have to do, you have to find out how much each number in the set is away from mean of the set, right? So first thing is you need to figure out the mean. So what is the mean of the set? Sum of all the numbers divided by number of items, which is 5 over here. So with this you got the mean, right? Now next you have to find out the deviation of each number in the set from the mean, right? So that means subtract the mean from each of the individual data point to find the deviation of each value from the mean, right? So with this, what we have how much 1 is away from mean, that is 1 is away from 5 minus 4, right? As it is on the left hand side. Similarly, 3 from 5 is minus 2. 5 from 5 is 0. 7 from 5 is 2. 9 from 5 is 4, right? So we got the deviation of each of these numbers. So that is the reason I told you that standard deviation takes into care of all the numbers in the set, while range takes into care of only the two numbers in the set. That is the least and the greatest. But here it is taking care of each number in the set. Okay. Now once you have the deviations, right, the next step is square these deviations. You have to square these deviations so that they should not cancel each other, right? So with this we got 16. The squaring of these deviations. 4, 0, 4 and 16. Next, you need to find the variance. Now, what is this variance? In order to find the variance, you have to calculate the variance by finding the mean of the squared deviations, what you obtained in the step 3, right? So, take the average of these squared deviations. So, 20 plus 20, right? 20 plus 20, that is 40 by 5. So, that this is 8. Now, 8 is the variance, right? Now, once you have the variance, what you need to do, you have to calculate the standard deviation. How to calculate the standard deviation? Take the square root of the variance, right? So just take the square root of root 8. So that is what is your standard deviation. So hope this is clear how to figure out the standard deviation. First step is find the mean. Second step is calculate the deviation of each of the numbers from the mean of the set. Third step is square the deviations, right? Next step is find the variance by taking the average of the square deviations, right? And the last step is, that is your fifth step, is finding the standard deviation by taking the square root of the variance, right? So one thing we can say about the standard deviation, that as the standard deviation is the square root of the variance, so standard deviation is always greater than or equals to 0. Right? So this is something again important. Now again it is earlier also it was asked on the data sufficiency question, and definitely Most of the time we do remember that standard deviation is positive, but we tend to forget that a standard deviation can also be equals to 0. All right. Now with this, tell me, when the numbers are quite close to the mean of the set, when the numbers in the set are quite close to the mean, what can you say about the standard deviation? Is it going to be high or is it going to be low? What can we interpret about the standard deviation? Yes, when the
Low.
numbers in the set are quite close to the mean. Right, because the deviation of these numbers in the set from the mean of the set will be less, right? So that is the reason if the deviation is less, of course the square deviation is going to be the less, then the variance is going to be the less, definitely the standard deviation is going to be the less only. So that means when the numbers are close to the mean, the standard deviation will be less. When the numbers are away from the mean of the set, right? Then what can we say, what can we interpret about the standard deviation? Yes, Delson? If the numbers are away from the mean of the set. Yes, Jalzan? Are you there? Jalzan, whether you got this point or not?
I'm so sorry.
No, it's okay. Or do you want me to repeat it?
No, yeah.
Yes?
Hello.
Jalzan, I'm sorry, I'm unable to hear you. Yes, what you said? I think there is some problem at your end because we are unable to hear you.
Hello. Wait.
Yes, yes, Jalzan. Tell.
So sorry, I think the power just went for a second.
Okay, no problem. Fine. Piyush, how will you interpret if the numbers in the set are away from the mean of the set?
Higher standard deviation on higher. Yeah.
Right. Definitely, we will have a greater standard deviation, right? Because the deviations of these numbers from the mean will be going to be good enough, and that will give the variance to be quite like we will have a high variance, and which will impact the standard deviation. Okay, so that's how we have the standard deviation rules. So yeah, Piyush, read these rules, please.
Sure. If all the elements of a set are the same, then the standard deviation of the set is 0.
Can you give the reasoning for this?
Yeah, so essentially there is no gap between the average and the numbers themselves because all the numbers is equal to average only, so there is no deviation as such.
Right. Right, there is no there is no deviation as such. Perfect. Right.
Yeah.
Second point.
If the numbers in the set are close to mean, standard deviation will be less, and if the numbers are away from the mean, the standard deviation will be more, just like we discussed.
Right. Something very important, right? Okay. Yeah. The third point.
If a constant is added to or subtracted from each element of the set, the standard deviation remains unchanged.
Right. So I would want Nisha to give the reasoning for this, why this rule is there. If a constant is added to or subtracted from each element of the set, the standard deviation remains unchanged.
Yeah, that's because it is going to be affected for every element in that set. So if we're increasing or decreasing, it will remain the same.
I mean,
Right. What will happen because
the relative distance will remain the same, right?
Same.
Even so.
exactly, very good. The relative distance is going to be the same only because what will happen if we are adding or subtracting a constant from each element, the mean is also going to be changed, right? The numbers are also going to be changed, and there's a reason the relative distance will remain same. Perfect. Right. The last pointer.
Yeah, if each element of the set is multiplied by the same constant, then the standard deviation of the set is also multiplied by the same constant.
Right. Here now the relative distance will definitely change, right?
Yes, definitely.
So I hope this is clear, all these four rules for the standard deviation. So you can see that when we add or subtract or multiply in case of the averages, what happens to the average? Now, when we do the same thing here in case of the for the like how it impacts the standard deviation. Addition subtraction does not change the SD, right? Only multiplication change SD. Whereas in case of average, when we do addition or subtraction or multiplication, the average also gets changed by the same operation, right? Okay, now let's do this question. Yeah, read the question here. Yes, Nishan, read the question.
Which of the following distribution of numbers has the greatest standard deviation?
Right, the question is asking for the greatest standard deviation, right? How can we do this? What is the first thing in order to figure out?
So we'll get to know the mean for each of these.
Right. So let's figure out. So start with the piece of information, what we know that how we can do this, right? So let's figure out the mean. So what is the mean for this set?
1. Oh, sorry.
Zero.
-3,
Zero.
1, 2. Yeah, I was thinking of more median, sorry. So it's 0, yeah.
Right, no problem. Yeah, 0. What about the second set?
0 again.
0.
Here,
5.
5.
right.
4. No, sorry.
2.
2, yeah.
Right. Mhm.
Again 2.
Again, it is 2. Right.
2.
Okay. Now what next? Once we have the mean.
So we'll see the difference between each of the numbers from the mean.
Right. So 0 from -3
-3.
is 3.
3, yeah,
Let's
3
take it
difference.
as 3 only, right? Because we are talking only about the deviation, or the, like we can say, okay, let's take this as the distance, right? The distance of 0 from -3 is 3. Then here 1.
1 and 2.
Right. So we got the deviations or the distance of these numbers from the mean of the set. Okay. Second, this one,
2, 1, 1, 2.
2, 1, 1. Right.
This is
Here,
2, 0, 2.
right. This one,
1, 0, 1, 2.
this is 3 now, I think. 0, 2, -1 now. 3.
-1.
3.
Oh, yeah,
What
3.
is the
Sorry.
distance?
Yeah, 3.
So that is the reason I said take the distance, right? So this is
Yeah,
3.
yeah.
Piyush
3,
and Delza, is
0,
this clear? Why
1,
we are
2.
taking it as 3? Yes, Piyush, Delza, is this clear? Why it is 3?
Yes, ma'am.
Right. So always calculate. In fact, instead of saying deviation, let's call it as okay, the distance of 2 from
Right.
-1. So that is 3. So that is the deviation basically. But take it as distance because distances are always positive. So then what 2 from 2 is? 0. 2 from 3,
2.
1, and then it is 2.
2.
Right. Then here it is 2,
0 and 2.
0, and 2. Right. Okay. Now, can we do process of elimination once we have the deviations in place? Yes, Delzan. Can we do the process of elimination? I think so. There is some connectivity problem at her end. Yes. Okay. Nisha, Piyush, can we eliminate immediately something?
Wouldn't we want to like take an average first, or just divide the
Let's
deviation?
not do that because if we take the average, okay, that again we can do. But then can we eliminate immediately something? We can eliminate C,
C and
202
E.
here.
C and E.
Right.
They
Because
can't
it
be
is asking
both.
for the greatest, we cannot have more than one option. So C and E is gone immediately. Right. Then,
I think, yeah, then I think then we'll have to take some averages or something.
Yes, we can take the average also, right? So 314, 4 to 6, 6 by 3. Instead of squaring, let us take the average of the distances. Okay. Got it, Nishay?
6 by 3 again, 6 by 4
Yes,
again,
ma'am.
Right. So this is 6 by 3. So this is 2,
2,
right?
then 6
And
by
this is
4,
8 by 4, right?
6
8
by
6
4.
by 4, ma'am. 2, 1, 1, 2.
This is 2, 1, 1, 2. So this is 6, 6 by 4, right? I'm so sorry. 6 by 4. So this is 3 by 2. We can eliminate this. Yes. Then this is already eliminated. So 3 plus 3, 6. 6 by 4 again, right?
Yeah.
This also we can eliminate. The answer is B.
Yeah.
Right? So, instead of taking the squares and then taking the average of those square deviation, instead of that, what you can do, you can take the average of these distances only. Once you have these distances from the mean, right? Take the average of these distances, and that's how you can get that. So, hope this is clear. Yes.
Yes, ma'am.
Yes, ma'am.